such an immense size that it could engulf Mercury and Venus and even come perilously close to Earth. Imagine witnessing a sunrise that takes up half the sky. Betelgeuse, one of the brightest and most famous stars in the night sky, has intrigued astronomers for centuries. Located about 6,425 light-years away in the Orion constellation, Betelgeuse is a red supergiant nearing the end of its stellar life. These types of stars, like Betelgeuse, are known to eventually explode in a supernova, an immense cataclysmic event that occurs when a star exhausts its nuclear fuel. Recent discoveries have heightened interest worldwide, especially following the announcement by renowned astrophysicist Neil DeGrasse Tyson, who revealed that Betelgeuse is on the verge of such an explosion. His prediction has sent shock waves through the scientific community, sparking speculation about the timing and impact of this monumental event. Tyson's announcement that the explosion could affect Earth within just 2 weeks has only amplified anticipation and anxiety. Before we delve into this exciting cosmic event, don't forget to hit the like and subscribe buttons for more exclusive news. Betelgeuse has long exhibited irregular periods of dimming and brightening, fueling speculation that it could go supernova in the near future. Due to its massive size, over 700 times the diameter of our Sun, the star's eventual explosion will be one of the most dramatic celestial events observable from Earth. Tyson's assertion that this event is imminent and could directly impact Earth has captured the public's imagination. However, it's crucial to clarify what direct impact means in this context. Although a supernova as close as Betelgeuse will certainly have widespread effects, it does not pose a catastrophic threat to life on Earth. This supernova will likely be a spectacular visual event, outshining even the full moon and remaining visible during daylight for weeks or even months. Historically, supernovae observed from Earth have left profound imprints on human culture, and Betelgeuse explosion is set to be one of the most significant astronomical events in recorded history. As Betelgeuse disintegrates, it will gradually fade from the sky, a disappearance that will mark the end of an era for stargazers and astronomers alike. However, this doesn't mean Earth will be bombarded with dangerous radiation. Despite its proximity in astronomical terms, Betelgeuse is still far enough away that any potentially harmful radiation will have dissipated by the time it reaches Earth. The primary impact will be visual, not destructive. Tyson's revelation has led to questions about what exactly happens when a massive star like Betelgeuse explodes. When such stars explode in a supernova, they release tremendous energy in the form of light, neutrinos, and possibly gamma rays. While these emissions travel at the speed of light, Earth's atmosphere offers considerable protection from harmful radiation. Neutrinos, for example, are subatomic particles that can pass through Earth without causing harm. Gamma rays, although more dangerous, will be significantly weakened by the time they arrive. While some predict minor disruptions to electrical grids or satellite systems, the most notable effect will likely be the breathtaking visual spectacle for skywatchers. For scientists, Betelgeuse supernova represents an unprecedented opportunity. These stellar explosions play a vital role in galactic evolution, dispersing heavy elements such as carbon, oxygen, and iron into space, the very building blocks of planets and life itself. When Betelgeuse explodes, it will scatter these elements, potentially seeding new star systems and planets far in the future. Astronomers around the world are preparing to observe the event closely. Instruments from space-based telescopes to neutrino detectors are being ready to gather as much data as possible. The event offers a rare chance to study a supernova in real time, providing new insights into stellar evolution, nucleosynthesis, and the intricate physics of these cosmic cataclysms. Betelgeuse explosion will also change the night sky. As a key feature of the Orion constellation, its absence will be deeply felt by those familiar with the stars. Orion has been a guiding light for sailors and a cultural icon for millennia. The loss of Betelgeuse will alter the sky's appearance, a reminder of the cosmos' impermanence, even as it opens up new avenues for scientific exploration. While Tyson's announcement has led to widespread speculation, it's important to understand that Betelgeuse poses no real danger to Earth. Supernovae release many types of emissions, but most of these will be harmless by the time they reach us. Earth's magnetic field and atmosphere will protect us from harmful radiation, leaving behind only an extraordinary celestial light show. In past centuries, Supernovae observed with the naked eye have made lasting impressions, such as the famous Crab Nebula supernova seen in 1054 AD. Betelgeuse proximity means this event could be even more spectacular, with its brightness potentially rivaling that of the full moon, casting shadows at night and offering a unique opportunity for photographers and stargazers to capture a once-in-a-lifetime cosmic event. Beyond its visual appeal, Betelgeuse explosion will provide a treasure trove of scientific data. Astronomers will study the light emitted during the explosion to learn about the elements created and dispersed in the process, enhancing our understanding of how stars shape the universe. This supernova also presents a chance to observe phenomena such as gamma-ray bursts and neutrino emissions, which remain poorly understood. Public excitement is growing, with many eager to witness this rare celestial event firsthand. Social media buzzes with discussions on where and when to view the supernova, and educational programs are being developed to help people understand the science behind this monumental occurrence. Schools and universities are seizing this unique moment to teach students about the life cycles of stars, turning Betelgeuse's impending death into a living science lesson. This streamlined version retains the essential details while improving readability. The creation of new forms in stars is a key point. When Betelgeuse bursts, it will throw out its outer cover in a huge shock blast, pushing material into the nearby cosmic space. This material, rich in strong metals like iron and carbon, will merge with the clouds and dust already existing in space, building the core elements for later star births. The force from the blast will heat and squeeze nearby gas zones, possibly starting the birth of fresh stars. Space watchers will have a chance to see this event over the next years and centuries, gaining rare views into the life stages of stars and the events needed for new stars to begin. The field of supernovae remains a fascinating area of study. The shapes left after a star's explosion are another subject that will gain from Betelgeuse burst. Supernova remnants are some of the most bizarre and stunning sights in the sky, made of growing rings of gas and dust lit by the light from the burst. These shapes are key to understanding how blasts spread heavy elements, which are needed for the creation of worlds and life. Betelgeuse remnants will give space watchers a fresh chance to look at the makeup and dynamics of starburst remnants, as well as the link between the ejected material and the surrounding cosmic clouds. One key question experts are keen to answer is what kind of core, if any, will remain after Betelgeuse explodes. When a star bursts, its inner parts shrink, and based on the size of the star, this collapse can form either a neutron star or a black hole. Neutron stars are incredibly dense, with the mass of the sun compressed into a sphere only miles wide, while black holes are regions of space where gravity is so strong that not even light can escape. Betelgeuse is at the edge in terms of mass, meaning that its fate might result in either outcome. If Betelgeuse leaves a neutron star, it will provide experts with a close sample to study, revealing valuable clues about the properties and behavior of these exotic objects. If it forms a black hole, it will be one of the nearest black holes to Earth, offering observers a chance to see how black holes interact with their surroundings. The study of black holes and neutron stars is one of the most exciting fields in modern astrophysics, and Betelgeuse explosion could lead to new insights on these enigmatic objects. For example, if Betelgeuse produces a neutron star, it might also emit light pulses. Neutron stars are fast-spinning stellar remnants that send out beams of light, which can be detected as regular flashes as the star rotates. The sight of a new pulsar in our galactic neighborhood would be a significant discovery, allowing astronomers to study its behavior and compare it with other known pulsars. Conversely, if Betelgeuse forms a black hole, experts will have the opportunity to observe how it interacts with the material left over from the explosion. This could lead to fresh discoveries about how black holes grow and evolve, as well as how they influence their environments. Betelgeuse explosion will also provide new avenues to study cosmic rays, high-energy particles that travel through space at nearly the speed of light. Supernovae are thought to be one of the primary sources of cosmic rays, as the shock waves from the explosion accelerate particles to extreme speeds. By analyzing the cosmic rays produced by Betelgeuse blast, scientists will test theories about how these particles are generated and how they propagate through space. This could have significant implications for our understanding of cosmic rays as a whole, as well as their potential effects on Earth. Another area of interest is the impact of the explosion on Betelgeuse nearby stars. Betelgeuse is located in a densely packed region of space, surrounded by clouds and other stars. When it bursts, the shock wave from the explosion will interact with these nearby areas, possibly triggering new star formation or altering the dynamics of the existing stars. Space watchers will closely monitor how the explosion affects Betelgeuse's neighbors, as well as the overall appearance of the Orion constellation. This will provide valuable data about how supernovae shape their environments and influence the formation of star clusters. The blast of Betelgeuse is also likely to emit a wide spectrum of radiation, from radio waves to visible light. Each of these emissions will provide different insights into the explosion and the processes occurring within the star. For instance, radio waves will reveal information about the star's magnetic field and the interactions between the shock wave and surrounding clouds, while X-rays and gamma rays will provide insights into the high-energy processes happening during the explosion, such as the formation of neutron stars or the production of cosmic rays. By studying the full range of emissions from Betelgeuse's explosion, astronomers will piece together a comprehensive narrative of the event and its aftermath, along with the scientific lessons that will emerge from this extraordinary occurrence. Beyond the scientific knowledge gained from Betelgeuse's explosion, there are also potential technological advancements that may arise from it. The data generated by the star will require new methods of analysis and interpretation, pushing forward developments in fields such as machine learning, computational techniques, and data science. For instance, the large volume of data generated by the explosion will necessitate intelligent systems to sift through and identify trends, potentially leading to breakthroughs in how we process and analyze large datasets. Applications that could extend beyond astrophysics. Furthermore, the need to visualize the dynamic processes occurring during the explosion will likely push the boundaries of simulation technologies, leading to new methods for modeling other stellar phenomena. Beyond the scientific and technological advancements, Betelgeuse's explosion will also prompt deep reflections on our place in the universe. One of the fundamental questions in astrophysics is the likelihood of life elsewhere in the cosmos, and supernovae play a crucial role in shaping the conditions necessary for life to emerge. The heavy elements produced by supernovae are essential for the formation of planets and the basic building blocks of life, meaning that without these explosive events, life as we know it may not exist. By studying Betelgeuse's explosion, scientists hope to gain new insights into how these elements are distributed throughout the galaxy, shedding light on the processes that lead to the emergence of life beyond Earth. Moreover, the explosion will provide an opportunity to assess the potential risks posed by supernovae to life on Earth and other planets. While Betelgeuse is far enough away that its blast won't endanger our planet, it serves as a reminder that we live in a dynamic and occasionally hostile universe. In the past, supernovae closer to Earth may have contributed to mass extinctions by releasing harmful radiation. Understanding how supernovae eject material and how this material interacts with planets is essential for assessing the risks associated with future supernova events. Betelgeuse's explosion will offer new insights that will help scientists evaluate the potential consequences of supernovae on planets in safe zones, adding to our knowledge of the factors that influence the emergence and sustenance of life. As Betelgeuse's explosion nears, it is also worth contemplating the profound and far-reaching implications of such a significant event. The death of a star like Betelgeuse, which has been a constant presence in our skies throughout human history, evokes reflections on the transient nature of celestial bodies. Stars are born, live out their lives, and eventually die, much like all living beings on Earth. The fact that we can observe and comprehend these processes is a testament to human progress, but it also serves as a reminder of the impermanence of all things. The blast of Betelgeuse may prompt us to consider our place in the cosmos and the legacy we leave as a species. Additionally, Betelgeuse's explosion could inspire new works of art, music, and literature. Throughout history, significant celestial events have often been interpreted as omens or harbingers of change. Although our current understanding of the stars is rooted in scientific knowledge, there remains something deeply moving about witnessing the death of a star. The explosion of Betelgeuse might inspire fresh artistic expressions as creators seek to capture the beauty and awe of this cosmic event. It could also rekindle public interest in space exploration and science, as people become aware of the incredible wonders that await us in the universe.